Okay, this is the exploring data video. So this is chapters 1 through 3 in our book. This is going over these 5 questions from your test on Tuesday. Just a quick little rundown of what chapters 1 to 3 we're talking about. This is not comprehensive, but this gives you a good little reminder. Chapter 1 was just the basics of reading all the different graphs, box plots, histograms, and all that. Summary stats, mean, median, standard deviation, the different relationships between those. Then we got into chapter 2. That's when we got into normal curves, just in general, calculating a z-score and percentiles. Remember, this does not mean it has to be normal. Normal has its own special layout, like the data falls into different sections in different proportions. Z-scores is just the basic idea of where do you fall in a set of data. Transforming data, what happens when you multiply, add, subtract to the data. And then we got into chapter 3, which we had our scatter plots. Let's see if I can get this on here. Scatter plots, regression lines, residuals, residual plots. What we are going to focus on is just going over these 5 questions, and then you're going to get some practice over the calculations necessary for chapters 1 to 3. All right. So, number 1, and I'm going to try to get as close as I can so this is not as small. Okay, on this one, it's talking about if we were to multiply each measurement by 100. So this is transforming data, chapter 12. Which of the following would remain the same? So the only thing that changes when you when you add, the center changes, but the spread would stay the same. When you multiply, then the center and the spread change. All right, so if I was multiplying every single number in this list by 100, the center, so that would cover mean, median, those would both change, so that's not the answer. Also, spread would change, so that's standard deviation. That would also change. Now, we didn't get into more specifics here, but maximum is more of a location. That kind of goes along with center. Location changes in both scenarios as well. So just by process of elimination, the answer is E. But the idea here is that z-score is not really a center or spread. It's a combination of those things, and it's giving you a relative location. If the z-score was 0, then you know you're at the mean. If you have a positive z-score, then you know you're above the mean. If it's a negative z-score, it's below the mean. So the z-score itself is a relative location within the data. So just by multiplying everything by 100, whatever value you're looking at is still going to be in the same location relative to the other numbers. Okay, so that's why the answer is E on that one. All right, next one, number 7, getting into that 5-number summary again. So it gives us the 5-number. Remember, lower quartile is just a fancy way of saying Q1. Upper quartile is just a fancy way of saying Q3. So we've got the 5-number summary plus the sample size. Which of the following is true? Be careful because it could say false. The smallest observation is 12, and it's an outlier. So it's talking about a bunch of outliers. So let's go over the outlier formula again. IQR, so that's Q3 minus Q1. So Q3 is 18, minus Q1 is 15. So the IQR is 3. You times that by 1.5, so that's 4.5. And then you basically take that and extend that either direction. So I'm going to add 4.5 up here, and I'm going to subtract 4.5 to get, like if you picture the box plot, there's the edge of the box, you're just going out from the box. So 18 plus 4.5 is going to give me, I want to say 22.5. I don't trust my brain right now. Yeah, okay, sorry, 22.5. So anything greater than 22.5 would be an outlier, and then anything less than, what, 10.5? Yeah, would be an outlier. So the lowest possible number is 12, so there are no low outliers, but the highest possible number was 24. That is higher. So all the ones that say that 24 is an outlier, we can still keep. But anything that says that 12 is an outlier, we can get rid of. So the only difference here is that B says that the largest observation is 24 and it is an outlier. No other observations in the data set could be outliers. And then this one's just allowing that there could be other outliers. The answer is E because 24 is the max. All we have to go off of is there's a number 18. So there could be any numbers between 18 and 24. We don't know off the top of all this data, and anything above 22.5. So if there's a 23 data point, it would also be an outlier. We just don't know, so it's a possibility. Okay, so that's how we calculate outliers. Now we're on number 11. This is looking at a box plot. Basically, if you read through all the descriptions, the answer choices, it's asking for which one of these is true. And it's talking about the medians and the IQRs being bigger or the same and all that. So the median, I'm just going to estimate on both of these. The median on this one, remember that's that middle line, looks like it's right at maybe like 150 or so. Whereas this one's definitely less than that. If I had to guess, I'd say it's somewhere, it doesn't really matter, it's just less than 150 for sure. And that's the unfertilized. So look through the choices. Anything that says the medians are the same. Median for the unfertilized is greater. Be careful, that's not true. It's the opposite. Median for the unfertilized is the same. I have a feeling most of y'all are capable of doing this problem. It's just a matter of reading carefully and keeping in mind that they're actually talking about this one first, which is a little bit backwards than probably how some of y'all read this. Median for unfertilized is less than. Okay, so then this one's saying that the IQR is greater versus IQR is less. So IQR is just this distance that spans the whole box. And obviously this one has the bigger IQR because the box is wider. So the unfertilized has and the IQR is greater for the unfertilized. So the answer in this case would be D. Okay, so again, I have a feeling most of us, if we did miss that one, it was just a matter of reading carefully. Okay, number 13, we're getting into some chapter 2 Z-score type stuff. So we have 2 6-year-old girls, that gives us the mean standard deviation of 6-year-old. It does say approximately normal, so if we need to use normal CDF, we can. So we've got 0.96 standard deviations above the mean. I'm just going to keep track as they tell us. So what that actually is describing, 0.96 standard deviations above the mean, is telling us that her z-score is positive 0.96. And then her friend Jane is also 6 years old, so all this stuff still applies to her, and she's at the 93rd percentile. So if I was to kind of sketch something out here, 93rd percentile just means here's Jane. We don't actually know what her height is, but we know that she's taller than 93% of girls her age. So at what percentile is, and I don't know how to say this, Aaliyah maybe? What is her height? So basically it's what is this percentile? So if we were to picture her graph, we know that she's above the mean. So I don't know what the mean is, but I know she's over here somewhere. Okay, here's the deal. This is a z-score, so we're talking about a standardized normal curve. So that means the mean is 0 and it's going out by 1 in both directions. So you can find her percentile, her area, by doing in normal CDF. So normal, oops. So the lower bound is basically that. Upper bound, we're going up to her 0.96 z-score, and we're going to leave it at our standardized 0 and 1. And so her percentile is about 0.83, it looks like. So she is at the 83rd percentile, so it's down to D or E, right? Because it's got the right number there. And then who's shorter? Is Aaliyah shorter or is Jane shorter? Well, since less people are shorter than her. Jane is further out, so Aaliyah is shorter than Jane. Answer's D. Okay, and then number 15 is the last one on this section. This is the only thing I had on chapter 3 from this test. So it gives you a scatter plot. It gives you a computer output over here. This is actually more straightforward than a lot of these are. Sometimes they don't actually use the word intercept and slope, but it's always in this order. So you can always go over here and use these two numbers to make your regression line, your least squared regression line equation. Okay, then it gives us this. So if we look, which of the following values is closest to the actual weight in pounds of the backpack for the student who had 4 books in the backpack? So we're looking at this guy, 4 books, We care about that point. This is be careful, the residual. So if I'm looking at this graph and like if I try to trace that over, I'd say the residual looks like it's a little bit above 2. Just barely greater than 2. But it's asking for the actual weight, which is y. And if you think about what we know about residuals, residuals are actual minus predicted. So if we can find the predicted, then we can work our way backwards. So we don't know what y is. We are going to find y hat, and then it's going to be about, maybe greater than, about 2. Make that about. Okay, so we have to use this equation I came up with to find the predicted y. Okay, and the x value that we're dealing with is the number of books, so that's the 4. So plug in 4 there. If you plug that into your calculator, it should give you, did this earlier, 12.65. So that is the predicted y value, and we're looking for this y actual, so you would just add that to the other side. So the y is about, and then 2 plus, so 14.65, but like we said, our residual looks like it's actually above 2, so that's an estimation, but we want to estimate up. So of the choices I have, 15 would be the most logical thing. So that was the answer there. So remember, for residual, it's actual minus predicted, so I always recommend thinking you're in an AP class. All right, get the the data worksheet, so I believe that's in pink.